Okay, we're going to look to solve this right triangle. And to solve a right triangle, that means you find all three sides and all three angles. So good news is the picture is always going to give you half of that information. So I'm looking at this right now, and I can clearly see that I have a right angle given, and that's here at 6. So I know the measure of angle C is going to be 90 degrees. Right, I don't need to really do any work to calculate that. It's right from the problem. And then I have two side lengths given. Now, they're not labeled in the picture as A, B, and C, so it is actually really important that we understand how the trig kind of right triangle notation works. Capital letters are for the vertices, so this is angle C. Directly opposite is going to be the lowercase letter, and that's going to be the side. So if this is angle C, directly across the triangle on the opposite side, this is going to be side C. So my side C is 3. So I'm going to put C is 3. So here, this is not labeled with one of the letters, but if I go across the triangle, I'm at angle B. So this means this side right here has to be B. So this is B is 2. So my side length here is 2. Okay, now I need to find the third side, and I also need to find a couple more angles. So I got a lot of options here. I can use trigonometry, right triangle trig. I can use the Pythagorean theorem, and I can use the triangle angle sum theorem. So right away, I'm looking at this, and look, I got a hypotenuse. The hypotenuse is 3. I also have this side right here. It's one of the legs of the triangle. It's 2. I need to now find this third side, which you could call BC. It is BC, but I'm going to use the notation here and call this A. It is opposite angle A. So I'm going to find this side. And I am going to use the Pythagorean theorem. I'm going to use A squared plus B squared equals C squared. And the nice thing about the way they do the sort of standard notation here is C is typically the right angle and C is your hypotenuse. So we can like clearly see here that C should be 3. So A is my unknown, A squared, B is 2 plus 2 squared equals 3 squared. I'm going to find this value right here. A squared plus 4 equals 9. Move it up a little bit just to finish solving this. I'll subtract 4 from both sides. So I get A squared equals 5. Now, in order to solve for A, I'm going to take the square root. So if I'm leaving it in simplest radical form, this is my final answer. I mean, I know that number is so small. I know it's not 5. It's not a perfect square, right? If I do the square root of 5, it's going to give me a decimal answer. And I can't simplify it because 4 doesn't go evenly into 5. And that's the smallest perfect square besides 1 under 5. So that's really my final answer. You could, if the directions don't say specifically, you could give an approximate answer. So about, 2.4, or sorry, 2.24 if I round to the nearest hundredth, or 2.2 if I round to the 10th, or 2 if I round to the nearest whole number. But I'm just going to leave it as the square root of 5. I like the exact answer. So I'm going to go ahead and put my answer up here. A is the square root of 5. And I am well on my way to finding all of my answers because I already know B is 2. And then I also have C here is 3. Now I need to work on the angles. So now in order to find the angles, I'm going to need to do some inverse trig. I can't use the triangle angle sum theorem because I need to have all three angles add up to 180, but I need to have 2 to get the third. So I'm going to go ahead and work on finding A. So let's see, I'll just mark that here in this diagram. This is angle A this time. So from here, I have 2 and 3. I also have the square root of 5, but I'd rather use these sides because they're whole numbers. They're not rounded, and I don't have to use the square root symbol. So from angle A, 3 is the hypotenuse, and A is the adjacent. So I should really be thinking, right, SOHCAHTOA, right triangle trig. SOHCAHTOA. It's my little cheat code to figure it out. And I have the adjacent and the hypotenuse. And the adjacent and the hypotenuse are here. That means I'm going to be using the cosine ratio. So I'm going to set up the equation using the cosine ratio. And it always follows this structure. The cosine of an angle equals the adjacent over hypotenuse. So it just goes now to the specifics in the triangle. I don't know the angle. It's unknown. I'm going to just use the capital letter A because that's the angle I'm trying to find. Cosine of A, set up the ratio. Adjacent is 2, and the hypotenuse is 3. Now, to solve here for A, I need to do the inverse operation of cosine. I need to undo the cosine. right? The calculator is really handy because the calculator is laid out to tell you the inverse operations. If you look at your calculator, you will see addition and subtraction next to each other, although my buttons are starting to wear off the plus the minus symbol. Multiplication and division are next to each other. Square and square root are listed together as a original button and a secondary pair. And then look, cosine, inverse cosine, tangent, inverse tangent, sine, inverse tangent. The inverse operation for your trig functions is almost always on every calculator model I've seen right above it. So to undo cosine, I'm going to use the inverse cosine. Now, in theory, I'm really doing this on both sides of the equation. I'm doing the inverse cosine of this, and I'm doing the inverse cosine of this ratio. Typically, when we're showing our own work, we jump right to A is the inverse cosine of 2/3. And the reason is, right, because these are inverse operations, they cancel themselves. Oh, right there where you can see it. Right, the inverse cosine on both sides, the inverse cosine and the cosine cancel. That leaves me with just A, and I'm doing the inverse cosine of that ratio. That's what I want to type into the calculator. I'm just going to double check I'm in the right setting. Tangent of 45 is 1. Good. So I'm going to do second, and then the cosine button. You need to get the inverse cosine. It should say cosine and then look like to the -1. The inverse cosine of 2/3. Oops. 2/3. Now this is giving me the angle. So A is, let's see, 48 point, I'll go hundredths place, 19. That's how many degrees this is worth. Always check the directions for rounding. Sometimes it will tell you specifically to round. It didn't. I don't. If it was on the handout I stole this from, I don't remember reading it, so I'm just going to go to the nearest hundredths place. Right, 1/8. That 9 tells me to round up, so that becomes a 1/9. Okay, I can now fill this in up here. The measure of angle A, 48.19 degrees. And now I don't really need trig anymore. I can just use the triangle angle sum theorem. I know all of the angles in the triangle add up to 180, so I can do 180 minus 90 and minus 48.19. And that's going to leave me here with 41.81 degrees. That gets me my final answer. Hope that's helpful. You have now solved the right triangle. You have all three sides and all three angles for this right triangle. Message me anytime with questions.